Scientists have created a new type of wiring that's not just lightweight and flexible, but also highly conductive enough to replace traditional metal wires in everything from motors to your toaster. And if this tech scales up, it could revolutionize electric vehicles, aerospace, and even everyday electronics. The secret is a manufacturing process called Lyotropic liquid crystal assisted surface texturing, or LAST for short. This method takes carbon nanotubes, which are already known for their incredible strength and conductivity, and solves one of their biggest problems: clumping. CNTs stick together in a messy tangle, which hurts their performance. But with LAST, researchers use liquid crystals to align them neatly while also removing metal impurities left over from production. And here's why that matters. Electric vehicles and aircraft weight is the enemy of efficiency. Take a Tesla Model S. Its dual motors weigh around 150 pounds combined, with about 25% of that being copper windings. Replace that with carbon nanotube wiring, and you could drop the motor weight by roughly 35 pounds. That might not sound like much on a 4,500 pound car, but it's not just about static weight. Less rotating mass means faster acceleration, better throttle response, and even gains in range thanks to reduced energy loss. But before we get too excited, there are some serious hurdles. CNT wiring still lags behind copper 7.7 megasiemens per meter versus copper's 59 MSM. In tests, a CNT-based motor maxed out at 3,420 RPM, while a copper version hit 18,520 RPM. That's a huge gap. However, the CNT wire weighed 1/5 as much, so when you factor in weight, the performance per pound isn't as far behind as it seems. Then there's cost. CNT wiring currently costs around $375 to $500 per kilogram compared to copper's dirt cheap 10. Making CNTs is energy intensive, relies on fossil fuels, and generates nasty byproducts like hydrochloric acid. Researchers believe further optimizations like better polymer sheaths or improved nanotube alignment could close the conductivity gap even more. And if they can crack high voltage applications, this tech could spread beyond motors into full vehicle wiring harnesses, aerospace systems, and more. For now, it's a promising glimpse into a lighter, more efficient future, one where carbon nanotubes might just untangle the limitations of today's tech. Please like, comment, and subscribe for more.